An endothermic reaction has an activation energy of X. Which reaction path diagram is correct for this reaction? So we know that the reaction is endothermic. And let me just clear it that before moving further, that an endothermic reaction. So there are two kinds of nature. There are two kinds of reactions in the nature: the exothermic reaction or endothermic reactions. And as their name suggests, they have their thermic terms, which is associated with the energy. So an exothermic and reaction is a sort of reaction in which the energy is released into the environment. All right, that exo means it's exiting the system. So energy is released to the surrounding. All right. So any reaction which is when happening, releasing energy to the environment is an exothermic reaction. Or the second term is endothermic reaction, which means uh, a reaction which needs energy instead of giving energy. So so in endothermic reaction, energy is absorbed into the system. All right. So energy is absorbed into the system in an endothermic reaction. So that's the basic difference between exothermic reaction and endothermic reaction. So if I want to figure out which reaction is endothermic, I first need to decide that I got reactants in a chemical reaction and I also got product, right? Because every reaction is having some reactants and a product, right? So reactants for an endothermic reaction, because it is the energy absorbing reaction, so this means the energy of reactants is lesser than the energy of product. All right, because energy is absorbed and the product will be having more energy than reactants, right? So clearly from these given options, first I need to filter out that which option is saying that product is having higher energy than the reactants. First option is option A, and we got option D. So we clearly eliminate option B and C, right? Now, another part is what is activation energy, right? So see, any reaction happening, it does require the activation energy, right? And any reaction, it could be any reaction, or so I should say every reaction needs activation energy to initiate the reaction, right? So if I look option A, it is saying that the X is representing the activation energy, because it gets energy, the reactant gets energy, and it gets the peak energy, which is the peak point where the energy is enough to propagate the reaction or to initiate the reaction, right? So we can say that energy is gained by the reactants and it reaches to the top or the enough point, or the benchmark for the reaction to happen, and then the reaction happens, and then we got products. So products are having more energy than reactants, right? Because they absorbed energy. They absorbed more energy than they released, right? Because this energy is released to the environment. This is the negative energy, and this is positive energy. So more energy is absorbed than energy released to the environment. This clearly shows that reactants are having, the products are having more energy than the reactants, right? So this is the perfect option we should go with. Or if I just do the critical analysis of option D, you can see that this is not the activation energy. Why? Because it's not starting from the reactant side. So activation energy should start from the reactants. Why? Because that's what activation energy means. Okay, how much energy reactants need to activate the reactant.